Hello, this is a lesson on colligative properties, mainly boiling point elevation and freezing point depression. And I'm going to have to try to talk kind of fast because the videos can only be so long. So if you get mixed up, you can always pause it. Um, First, boiling point and freezing points are affected by the addition of a non-volatile solute. That means like a solute that does not evaporate very easily, like example, salt, sugar, things like that. Um, and I'm first going to talk about those that are also non-electrolytes. So like for example, sugar. Sugar, when it dissolves, it stays sugar. It doesn't break out down into ions. Here are two equations that you need to make sure you learn. You need to know this equation right here and this equation right here. Here, this means change in. The triangle means change in. And the T is temperature. So here where I have TB, that's the boiling temperature. TF would be the freezing temperature. KB is the boiling constant. KF here is the freezing constant. And you should know already from previous lessons that the little m, that's italicized there, that's standing for molality. So there we have, it's basically the same equation, but depending on what you're doing, whether you're doing boiling point or freezing point, then you'll use that. Well, we found out that here is that whenever you take a solute and dissolve it in water or any solvent for that matter, we'll just use water as example, what's going to happen is as you put particles into that solvent, the boiling point will get lower. Excuse me, the freezing point will get lower. The boiling point will get higher. So for example, the normal freezing point of water is 0 degrees Celsius. Well, if you add a little bit of salt, like they do when they're putting salt on the roads, then now salt dissolves into that solute, makes it impure, and causes the freezing point to get lower. So for example, it might be instead of 0 degrees Celsius, it might be a -1 or -2, or it may not even change that much. If you, and the same thing happens to the boiling point, but instead of the boiling point getting lower, the boiling point gets higher. So again, using water as an example, if the boiling point of water is 100 degrees Celsius and you add something to it, salt, sugar, some kind of solute, what's going to happen is then now instead of boiling at 100, it may boil at 101 or 100.5 or something like that. Now, here's a problem that I'm going to do for you. And basically it says that, first let me remind you of the tips here. We're looking for calculate the boiling point. So I got TB equals KB times M. Now I've written over here, I'm going to put a little green box around it. This is the boiling constant and the freezing constant for water. So only if your solvent's water does that work. And so now I'm going to move to the problem. If you'll notice here, I'm looking for the change in the boiling temperature. I can put that 0.5 in, 0.51 in for KB, but I don't know molarity. But look in the problem, I'm given the information for molarity. I have 4.9 grams of solute and 175 grams of water. So very quickly, let me calculate the mass. This is solute. I'm going to divide that by 342 grams per mole. If I do that, that gives me moles. And to get molality, I'm going to divide by 0.175 kilograms. All right? So for my molality, I'm on 0.082 molal solution. So now I can go back and put this number in for the M, and I've got this number that I'm putting for the KB. So what I'm going to get here is I'm going to say 0.51 degrees Celsius molal times 0.082 molal equals 0.042 degrees Celsius. Now that equals my change in temperature. It doesn't equal the boiling point. The boiling point of water normally is 100 degrees Celsius. And since we're adding a solute, it's boiling point elevation, that means it's going to go up by 0.042 degrees Celsius. And that's going to give me 100.042 degrees Celsius. Now, I'm not really going by significant digits here because I want you to see that it brought it up, but not a whole lot. Okay? I'm going to extend the page here. If I wanted to do the freezing point, which is also that same problem, I'm going to use this formula. And my M hasn't changed any. So now I'm going to use the 1.86 degrees Celsius molal times my molality, which was 0.082 molal. That comes out to be 0.153 degrees Celsius. Molal canceled out here. And since it's freezing point depression, that means it's going to go down by that much. So I'm going to say 0 degrees Celsius, which is the normal freezing point of water, minus 0.153 degrees Celsius. And so my answer is a negative 0.153 degrees Celsius. So here I was able to calculate the boiling point change, the final boiling point after it was elevated, the freezing point change, and the freezing point after it was elevated. Now let's move on to our next page. And this is, what if you have a colligative property that is an electrolyte? Electrolytes break down into ions, and what I mean by that is if it's something that breaks down, it'll be something like NaCl, gives me an Na plus and a Cl minus. So I have two particles. Or if I had CaCl2, that would give me one Ca and two Cl minuses. So that breaks down into three particles. We're going to take that to account, and that comes into our I spot. And so what we're going to do is we're going to do the exact same kind of problem, but we're going to have to multiply it by the number of particles. Okay, here's another problem, and what we're going to do is we're going to find the freezing point of this one. So we want the freezing point, so I know I want to use this formula. However, when I get to this, I have this compound. That is an electrolyte, and it will break down into three particles, one calcium and two nitrates. It looks like this. Okay, so it's 1, 2, 3 particles. All right, so I'm going to have to put that I on there too, since it breaks down into 3 particles. And so what I'm going to do is I'm going to take my information. I don't have to find molality because it was already given to me. So I'm going to say my delta TF equals 1.86. Remember, that is the constant for water, times my molality, which is 0.5 molal, times 3, because it's dividing up into 3 particles. And what I'm going to do when I get that answer is I'm going to get 2.79. So my change in temperature equals 2.79 degrees Celsius. Molal canceled out. Now, again, and let me just erase this down here for a minute. Okay, so again, that gave me my change in temperature. The question didn't ask for what was the change in temperature. The question asked for what was the freezing point. Since the freezing point of water is normally 0, and freezing point depresses or get the lower, I'm going to subtract 2.79 degrees Celsius, and my answer is going to be a negative 2.79 degrees Celsius as my boiling point. Just remember when you're doing these problems that you want to make freezing point go down and boiling point go up. I know I did this pretty quickly. However, if you get stuck, pause it, figure out where I got the numbers from, and go from there. Good luck.